So, good morning and welcome everybody. It's great having so many people here on the last day after a really amazing but also exhausting week here on the conference. And I'm not just referring to the sessions at the day, but by Priebe in Vegas. So much appreciated that you show up early in the morning here. So my name is André. I'm the CTO of IC Consult. We are a system integrator completely focused on identity and access management. And well, as part of our projects we are delivering for customers, we had several projects in which IoT was involved. And to be honest, that was not always very straightforward. Yeah? Therefore, I would like to share a little bit these experiences today and looking into the standards which we see there. Okay, let's jump into that. What is IoT, Internet of Things? Well, we are talking about connected devices here. And there are the questions, what is a connected device? Typically, we don't mean in that context a smartphone, a notebook, a tablet, a server, and a data center. They are all connected, but hey, they are not constraints. That's our typically device. We are talking here about devices which getting that connectivity and are very constrained, and typically not in a data center, but somewhere at the edge, in your household or in a very remote location. There are different categories of connected devices, and well, the largest ones are consumer electronics, and what a surprise, connected vehicles, smart grids, but there are a couple of others when it's about inventory and so on. The exciting part here is every single segment is growing, and we expect to have nearly 30 billion connected devices in 2030, which is an impressive number. And what is also a good reason that we as IAM professionals should think about how to deal with the challenges around these devices. I want to explain the use cases, the challenges based on a very simple scenario about connected vehicles. This will be very superficial. If you're interested in how really use cases for connected vehicles look like, I can recommend have a look to the presentation Steve Vihima did that week, was just focusing on that topic. Anyhow, so very simple scenario. We have a user, we have a vehicle, and an app. Maybe we want to locate the vehicle with that app, right? Of course, the vehicle has to have an identifier. Vehicle identification number or a technical identifier. And that app instance has to be somehow authorized to locate that vehicle. Do we need the identifier of the end user for that? Not necessarily. You can link the app to the car while being in the car the first time, things like that, and there's no end user identity required. Will the engineers building that kind of functionality reach out to identity guys up front? Likely not, right? So that feature is there and it's fine. And then other use cases typically come up, driven by other parts of the organization, and maybe sales, not just to buy that vehicle, but maybe also to buy additional services, digital services on top of the vehicle at a later stage when we really want to have that connection with the end user identity, or to enable features in the car. For instance, a feature to remove or upgrade the speed limit from 250 kilometers per hour to 280 kilometers per hour, which translates to something like 170 miles per hour. Well, and I'm from Germany, as you can hear. on the German Autobahn, this is a thing, right? Okay, after sales, the car is sending telemetry data, and maybe we get aware that there is a good reason to go into the service with the car. Yeah? And that makes a lot of sense, having that connected with the end-user identity, because in the head unit we might want to integrate further third-party services. For instance, Office in the car via Microsoft 365, these kind of things, in which we then can easily look up the calendar of the user. User can select, okay, that date is fine to go to the service. Or using all the nice digital assistants out there, Amazon Alexa, to start the preconditioning of the car. Very convenient. Or foreign organizations, which, for instance, a car rental company wants to provide a user journey in which the user is getting a digital key to the phone without showing up at the counter at all. Yeah? Well, if you look to these three participants, these are outside the organization. We can influence the application, the code, the solution within our organization, but not outside the organization. And this is now really the point in which robust foundation of standards helps a lot to build these kind of use cases at scale, and not having a couple of one-to-one use case implementations, which obviously will not scale. So therefore, let's look a little bit into the world of standards in IoT and identity. Here we see the IoT standards in the top part, and there are many of them, just a small selection. We have standards like MQTT, a publish-subscribe protocol with very, very less overhead, very efficient, more than 20 years old, or SAML, a single sign-on protocol. I'm quite sure most of you are somehow familiar with that. Guess what? At the point of birth for these standards, nobody was really thinking about how will they play together, right? There were no apps, no mobile, no smartphones, and so on. It was a complete different time. Then we have standards like Zigbee, which is heavily used in home automation scenarios to connect the smart bulb with a gateway component, or protocols like Web of Things, a very modern REST-style protocol, which allows you to call action on devices, or to get metadata, understanding of the capabilities of the device, or the very new last year published Matter standard, also home automation. On the identity side, we have a couple of standards for single sign-on, authentication, authorization. I think there were a couple of talks, and you are familiar with a lot of these standards, so I don't want to go into the details in explaining these standards. That doesn't make a lot of sense. But what I would like to do is categorizing these standards a little bit. So if we now define 3 levels for the authentication, authorization capabilities, when it comes to device identity and user identity, we have the level 0, no authentication capabilities at all. When it comes to level 1, we might do not have the capability to identify the device, but at least an application, so a non-human being identity. Or we are able to have at least a basic authentication, or can reuse an existing token, something like that. So limited capabilities, or really substantial capabilities for authentication of devices and users. So these are the categories. And now let's have a look how these protocols play, are somehow categorized in that landscape. And what we see is we have one group of protocols, the device-centric protocols, which are doing very well when it's about device authentication. Okay, most of them. And the same is true for the protocols in the user identity landscape when it's about user authentication, authorization, and so on. What is here the important area to look at? We have a few protocols which are taking at least a little bit of the user identity into consideration. Yeah? Web of Things is fine if you send an OAuth token in the header. That's it. What you're doing with it, that's up to you. Or FIDO device onboarding, which allows us a late binding of a device to an IoT platform, is at least working this kind of vouchers which the user who is connecting the device is using. When we now look to the identity standards, we see most of them are somehow not just identifying the end user, but having also a relationship to the application, the audience, the OAuth clients, the OpenID Connect relying party, and so on. Is this the same like a device? No, it isn't for several reasons. I don't want to go into these details. But what we see is we don't have any standard which is really focusing on the device and at the same time on the end user identity. Well, is this an issue? Maybe. Let's have a look to the typical use cases we have, and now not just on automotive level, but more generic, and then think what is the result based on that when it comes to the finding from the previous slide about the capabilities. Well, lifecycle management of a device, okay, that's clear. By the way, we are first have a look to the administrative use cases, so use cases which are typically happening once or from time to time, but not on a very daily basis. Then onboarding of the device. So the device is getting some credentials, it's maybe connecting to the digital twin on the IoT platform, these kind of scenarios. And then we have the claiming. End user is claiming ownership, control over that device. Yeah? And this is a very important one. Why? It's clear here we have end user interaction. And if you are a product manager for a physical product which is connected, you will pay a lot of attention to that use case. Why? This is the first interaction your customer has with your product, right? So that's a very, very important one. And it's depending on the device and use cases, not just, hey, I'm connected to the device and that's it, but maybe I also want to delegate privileges, yeah? To my family members, for instance. Yeah? And one example, let's come back to the example about the speed limit I want to remove from the car. I don't want to remove my kids doing that, right? That's one of the examples. Now let's have a look to the runtime use cases. The runtime use cases are a lot about access to the device, authentication, authorization. And for these use cases, we see that their challenges come up. Why? Well, as said before, the point in time in which the engineers are developing the product, they don't pay a lot of attention on the end user identities. Anyhow, to have authentication in place, we have to bring together the end user identity and the device. We'll look into that a little bit later. For authorization, we have to have a very, very good understanding what kind of relationship was introduced during the claiming or a later stage during the delegation of privileges. And that's not something what just has to happen on the identity side. The same thing has to happen on the IoT side and maybe for a couple of middleware components in between. Think about a zero trust architecture. We have an API gateway acting as a policy enforcement point. Well, then that component has to have a good understanding how to get how to use that kind of relationship for an authorization purpose. Yeah? And then one use case I would like to mention is acting on behalf of. For instance, let's look to a dishwasher, a smart connected dishwasher. So the dishwasher has a cartridge with soap for 30 days. Yeah? And as you are buying these cartridges, it's the e-commerce system of the vendor, of the dishwasher. The dishwasher is somehow aware how many cartridges are still in stock at home. Yeah? After you inserted the last one, hey, dishwasher, you should order new ones on my behalf, maybe given in a given price range. So these kind of use cases come up here. So now, what is in the current state when we look at the standardization we have in IoT and identity? So we have a lot of standards focusing on the one or other side, and the IoT protocol will not be chosen based on the identity requirements and likely vice versa. We don't have any standards covering both aspects at the same time, and that is especially true for the relationship between the device and the user, which is important, as this is really the part which requires a lot of design work and implementation work. And also, if you are looking to the IoT standards, especially the ones which are not HTTPS-based at all, they do not play very well together with the identity standards. Based on that, we have for projects in which we are not just having identities of end user, but of devices and the use cases I mentioned before, really a lot of implementation which is done in a kind of proprietary way, as we cannot just leverage the existing standards we are typically used to onboard applications into the identity access management system. So there's a gap we have to be aware of. So what is the learning based on that? There are challenges, and I want to go a little bit through them, that you are aware of them if you are starting an IoT project and can tackle them in an early stage. So first of all, missing guidance. It isn't a kind of standard approach. Hey, I'm building a mobile app and want to have the user to authenticate. There we have, for instance, OAuth 2 for native apps, which gives guidance to the developers of the mobile app. That's not the case in the IoT landscape. And if the engineers which are absolutely aware of the IoT protocol select the protocol, they will typically not think about, hey, how can I authorize the end user somewhere in the future? That's also very true if you look to the limitations of the protocols. One example I want to share, I think it was using MQTT, of course, user authentication was for that device required. Otherwise, it would not be an issue. What happened? The device has a virtual keyboard. So the user can theoretically type in a password. A keyboard, just capital letters. In a scenario in which the end user could use a password, in that case, there was a policy defined, capital letter, numbers, special characters, and so on. Or decide to not use a password, having a one-time password via mobile number, via mail, or using a third-party login like Google or Apple. So you can imagine how good does it work with that device and the virtual keyboard which has been implemented for that specific device, right? And these kind of things then come up not at the first day of the project, but as soon as it comes to integration between the IoT development on the one side and the identity access management on the other side. So what is to say about user authentication at the device? It's very important to find a way to get over the limited capabilities of the device, for instance, by leveraging things like a QR code-based login via OAuth 2.0 device authorization grant. If all other applications are integrated via OpenID Connect for authentication, then you cannot assume that the product you are using is supporting the OpenID Connect ID tokens also while using that QR code-based flow. That's not part of the defined standard. Might work, might not work. If you have the code under control, great, you can implement it. Otherwise, you might run into a challenge here. Then we talked about claiming the device, which requires a lot of design work in order to store that relationship. Typically, the IoT engineers want to store that in the IoT system as they required for a couple of tasks. But when it then comes to more use cases like, hey Alexa, start the preconditioning process, or the use cases in the e-commerce system, then the other systems already integrated with identity access management, they need to have that kind of relationship, right? So you have to design it, you have to find a way to put that into the tokens you are using for single sign-on to provide that information. Yeah. We covered the authorization aspect, offline access, a car in the parking garage. You cannot expect it to be connected, to be online all the time. So that's something we have to deal with, and what is typically not very well working with the standards we use for single sign-on authentication. Okay, the limited capabilities of the devices, especially when it's about interacting with users, and then the different protocols where we have to build a bridge somehow in between. My strong recommendation is, as soon as you as IAM professional get attention that in your organization there's an IoT project is ongoing, reach out to that people and discuss how the integration can look like. That really must happen in the design phase. It isn't working at a later stage very well. That's an experience we had to make in the past a few times. So, thank you very much. I think we have a few minutes left for questions. Any questions? Okay, then I have one question. Who has, from a professional perspective, an IoT scenario right now, or upcoming, or in the past in his organization he has to tackle? Okay. All right. Yeah. Then, thank you very much. Enjoy the last sessions here today and have safe travels home.